Okay, so you can actually make AI better at reasoning by teaching it to think backward. It's
Hmm.
kind of like when you're double checking your work, but instead of like retracing your steps, you're working backwards from the solution
Oh,
to
interesting.
see if it all still makes sense.
Yeah.
And that's what this research paper we're diving into today is all about. Reverse thinking makes LLMs stronger reasoners.
Okay.
And they found that they could get these large language models,
LLMs?
yeah, the LLMs to get way better at reasoning just by incorporating this reverse thinking into how they're trained.
Huh. So they're basically trying to take something that humans do naturally, like this backward thinking,
Yeah,
and then use that to make AI even better.
exactly. And you might be wondering, how do you teach an AI to think backward?
Right.
It's not like you can just tell it, hey, think backward now.
Yeah. I mean, AI training is already super complicated, right? You have to give them tons of data and then fine tune them to do specific things.
Exactly. It's a whole process. And in this case, the researchers came up with this approach. They call it rethink,
Rethink.
to think.
Okay.
And it has two main parts.
Okay.
First, they change the training data in a really specific way. And then they use something called multitask learning to actually train the AI.
So let's start with the data part, the data augmentation. What exactly are they doing there?
So instead of just adding more data,
Hmm.
they use a bigger, more powerful LLM.
So another AI.
Yeah, they call this the teacher model, and they use it to create extra data that specifically teaches reverse thinking.
So the teacher model is showing the way, kind of
Yeah.
showing how to think forward and backward.
Right. So for each question in the original data, the teacher model does three things.
Okay.
First, it gives you a step-by-step solution, kind of like showing your work on a math problem.
Okay.
Then it comes up with a backward question based on the answer.
So for example,
Yeah, like if the original question was, Emma has 2 apples, Jack has 3, how many do they have total?
uh-huh.
The backwards question could be something like, if they have 5 apples total and Emma has 2, how many does Jack have?
Right. So you're kind of flipping the script.
Yeah, exactly. You're forcing the AI to think about the problem from the other direction, like starting at the end and working backward.
Interesting.
And then finally, the teacher model gives you the reasoning needed to answer that backward question.
Again, step by step.
Yeah, showing all the steps.
Okay, but how do they know the teacher model is giving them like good information? I mean, AI isn't perfect, right?
Right, that's an important point. And they actually have this whole filtering process.
Okay.
They only keep the new data if the forward and backward reasoning all line up perfectly.
So they get rid of anything that doesn't make sense.
Exactly, no flawed logic allowed.
That makes sense.
So now they have this improved data set, all set up to teach this reverse thinking. And that's where the multitask learning comes in.
Right, right. So how does that work?
So they train a smaller LLM, they call this the student model,
Okay.
and they train it on this new data.
But they don't just make it solve problems in the regular way, right?
Right, instead of just learning to solve problems forward, they actually make it learn 3 different things at the same time.
Like what?
It has to learn how to do the forward reasoning, how to generate those backward questions, and then also how to do the backward reasoning.
So it's like they're giving it a mental workout, making it think in multiple directions.
Yeah, exactly.
Okay, I'm following so far.
But here's the thing, when they actually test the student model, they only give it the original question, and it only has to give the forward reasoning.
So all that backward stuff is kind of like a secret weapon.
Yeah, it's like it's shaping how the AI thinks without actually being part of the final problem-solving process.
That's really clever.
And it seems to work really well. The results are actually pretty amazing, but we'll get into that after a quick break.
Oh, all right. I'm definitely curious to hear more.
We'll be right back.
All right, spill the beans. How much better did Rethink actually do?
So on average, Rethink made the student model like 13% better at reasoning tasks compared to just using the regular zero-shot prompting.
13%. Huh, that's pretty good.
And it beat other methods too, like knowledge distillation, by a lot.
Hmm.
But here's the kicker. It did all that while using way less training data.
Oh, wow. So it's not just better, it's also more efficient.
Exactly. Sometimes it even did better using only 10% of the data compared to other methods that used like all of it.
So you could get the same results with much less effort. That's a big deal.
Yeah, it means we could maybe use these fancy reasoning AIs on devices that don't have as much power.
All right, it could make AI more accessible.
Yeah, and the researchers didn't stop there. They did all these extra studies to figure out like how Rethink was actually working.
Ah, trying to peek under the hood.
Exactly. And one thing they found was that all three of those learning objectives were important. You know, the forward reasoning, the backward question, and the backward reasoning.
You couldn't just take one away.
Right. If you got rid of even one, the performance dropped.
So it's all connected. It's not just about thinking backward. It's about how you train it to do that.
Yeah, like giving it the whole toolkit for thinking in both directions.
Makes sense.
They also found that the way they combined all three objectives into one learning process was super important. That gave them the best results.
So there's something about learning all these things together that really makes a difference.
Right, like it helps the AI understand reasoning on a deeper level.
Huh, very interesting.
Oh, and they compared rethink to this other method called answer augmentation.
Answer augmentation, what's that?
It's where you just add more correct forward reasoning chains to the data, like giving it more examples of how to solve problems in the regular way.
Okay.
And it did help a bit, but when they combined it with rethink, the results were even better.
So rethink works well on its own, but it can also make other methods even better.
Yeah, like they can all work together.
Now, what about those different types of problems? You mentioned they found that rethink was better at some than others.
Right. So they found that rethink was really good at what they call invertible problems.
Invertible problems.
Yeah, it's like if you know the answer, you can work backward to find the original values.
Like a math equation.
Exactly. Or like a recipe. If you know the final dish, you could probably figure out the ingredients and the steps.
Right.
And Rethink was great at these kinds of problems across all sorts of subjects.
But for problems that weren't so easy to reverse, the improvements weren't as big, right?
Yeah, that's right. Which means that the type of problem you're trying to solve really matters.
It's not a magic bullet.
No one size fits all in AI.
Now, what about this medium hard thing you said Rethink was best at those?
Yeah, it's kind of strange. It wasn't the easiest problems or the hardest ones. It was the ones in the middle. Like there's this sweet spot of difficulty where reverse thinking really shines.
Maybe it's because those problems are hard enough that you need the extra check of reverse thinking.
Yeah, but not so hard that the AI gets totally lost, even with the extra help.
That's an interesting thought.
It really makes you think about how reasoning works, both for humans and for AI.
Absolutely. So much we still don't know.
Now, we've talked about all the good stuff, but of course, there are some challenges too.
Like what?
Well, the researchers pointed out that the quality of the data used to train the teacher model is really important.
Right, because if the teacher model learns from bad data, then it could pass those problems on to the student model.
Yeah, like a game of telephone, the message can get messed up along the way.
So we need to be careful about what we're feeding these AIs.
Yeah, making sure the data is good and fair is a big part of responsible AI development.
Absolutely. We want AI to be helpful, not harmful.
Right, and we always need to remember that AI is a tool. It's here to help us, not to replace us.
It should make us better, not obsolete.
Exactly, and this research on reverse thinking really shows us that the future of AI is in our hands.
Oh, hey there, what's up?
Hey there, if this work doesn't work, which reason can we infer?
Okay, so when you say doesn't work, you're touching on a really crucial aspect of this research.
Yeah, it's not like a magic wand, and the researchers even point out the limitations.
Exactly. The whole idea of reverse thinking is powerful, but it's not universally applicable, and it's definitely not a guaranteed fix for every AI problem.
And like we mentioned, the study found that the biggest improvements were for those invertible problems like math equations or puzzles where you can actually work backward from the solution.
Right, and we also saw that the data quality matters. You can't just throw any data at it and expect great results. If the data is bad or biased, it's going to mess up the training.
It's like the AI can only be as good as the information it's learning from, and the process they use to verify the data is a crucial step.
Well, that's a pretty direct statement.
Yeah, it sounds like you might be skeptical about this whole rethink. Oh, yeah. Go on.
If this work doesn't work, which reason can we infer?
Oh, yeah, uh-huh.
If this work doesn't work, which reason can we infer?
Okay, that's a great question. If reflect doesn't work, it's likely due to a few reasons the researchers themselves identified.
Yeah, like remember how we talked about how the method is best for invertible problems?
Right. If a problem is too abstract or doesn't have a clear backward path, the method won't be as effective.
Also, it's super important that the teacher model gives good data.
Exactly. If the teacher model's reasoning is flawed or the backward questions are poorly generated, the student model won't learn correctly.
It's all about the quality of the training data and the way it's used.
And that's why they have that verification process that we discussed, where they make sure the forward and backward reasoning align.
Yeah, if that verification process isn't good enough, then the data the student model learns from isn't going to be very good.
So in short, it's not that the method can't work, it's that it's dependent on certain conditions being met, like the problem type and data quality.
Okay, so with all that said, where were we?
I think we were just about to get into the challenges that the researchers highlighted in their paper.
Yeah, that's right. So we've talked about the strengths of Rethink, but it's important to be realistic about its limitations, like we were just discussing.
Right, and that's actually pretty standard with any new method for training AIs.
Yeah, and they really made a point to emphasize that the teacher model's data is super important.
We've discussed that a few times now, but it really is a key point.
Yeah, because if you don't start with good data, then the AI is just learning like bad habits.
It's like teaching a kid with a bad textbook. You wouldn't expect them to learn the right information.
And also, we need to remember that even though Rethink is really good at specific tasks, it's not going to be able to solve every problem.
Exactly. As we mentioned before, it really shines with those types of problems that have an obvious reverse.
Yeah, and it's not like a one-size-fits-all solution. It's a tool that works really well in some cases, but not in every case.
So we can't expect AI to solve all the world's problems right now, even with cool new methods like this one.
Yeah, we still have to do the work both in the AI and in like how we apply the AI.
Absolutely. And as we learn more about AI, it's important to keep asking the tough questions.
Yeah, like are we using it ethically and is it benefiting everyone and all that?
It's a shared responsibility, and we should always be working together to make sure that